Okay, so if we take triangle ABC and we know that angle B is 63 degrees, angle A, or side A, which is opposite angle A, is 29. Side C, which is opposite angle C, is 38. And we want to find the other pieces of this triangle. So SAS tells us we have one triangle, and we'll be using the law of cosines for this. Again, SAS and SSS are the patterns for law of cosine. Okay, we're going to start with the unknown. The unknown is the side opposite, or the side opposite the angle of our SAS pattern. So when we look at that, we get side squared B squared is equal to the sum of the squares of the other two sides, minus twice the product of those two sides, all times the cosine of the angle opposite that. Okay, so we can use the solve feature, F2 algebra tab, type in what we want. I'm going to use x instead of b just to make it easier. All right, so I'm going to plug in my cosine of 63 and then solve for x. I put a decimal here, so my answer will be displayed as a decimal. I get side B to equal 35.84 approximately. Okay, and so what I need to do next is find one of my angles. And you can use, now that you have this measure, 35.8 approximately, and you can now find either A or C using either law of sines or law of cosines. Either one will be fine. Okay, I'm going to set it up using law of sines, and I'll find A. Okay, so the sine of A over the side opposite it, 29, is equal to the known ratio, which is now the set, the sine of 63 over the side opposite it, 35.8. Use the solve feature. Once again, we can't actually solve for A inside of a trig ratio, so we'll let x represent the sine of A and solve for that x. So F2 algebra tab, enter our equation. X divided by 29 is equal to the sine of 63 divided by the side that we just got, which again I'll have to delete the negative part, and I'll delete the x equals part. And then at the end of this, I can solve for my x. This is going to give me my sine ratio. I expect it to be between -1 and 1. I get a value that fits those conditions. And so A itself can be found by taking the inverse sine of that ratio. And so the easiest thing for me to do is just take the inverse sine of x, close it off, use the with key, and then highlight what x is equal to. And when I do that, I get 46.1 as my angle. And so it looks like they didn't use the exact answer. They used just 46. But once you have this measure, you can take the sum of the angles, 180, subtract what you have, 63 and this 46, and that leaves you with your remaining angle of 70.8 or 70.9 in this case. Thank you. And so you get, this is angle A. That means angle C is going to be 70.9.